All right, hello. This is Kevin from Jaseki Labs, and I'm gonna walk you through sort of the setup and how I created the LLM docs for Jaseki. And so LLM docs is the idea behind it is that it's a very condensed document for LLMs to read for them to gain knowledge about something. And so here's some examples. Here's the website that we got the idea from, and you can see like here are some like libraries that you would want an LLM to learn. And so if you were to search like something like React, you would have the version number of whatever library that you're trying to create docs for, as well as the type. And the type is sort of like the size, and you can see here the minified or the slim is the smaller sizes, while like a full React doc can go up to 128,000 tokens, which is a lot. And so if you look at one of these, it's just a plain text file with React, some of the most basic React syntax in there. And so this is what we were trying to implement. So I've been working on this for a little while now, and I can show you, don't look at that yet. This is my workspace. And so how I've set this up is that from the Jaseki documentation, I've extracted, or rather, where's tree or docs? I've extracted sections where I think is useful. So for example, here's the Jack book, and here's like the traditional way you would learn Jack. And so you have all those markdown files here. And so I think doing this by hand is basically impossible, right? So what I did first was, based on the stuff in docs, I used these combinations of these documentation things to create versions of like raw docs, because LLMs aren't great at doing everything in one step, and especially for a big task like this, it's much better to have LLMs try to summarize only one thing. So for example, in DocsGen, these are basically like unprocessed docs focusing like maybe on one thing. So here's a doc that just summarizes the process described in Jack book, and here are maybe two docs that focus only on the syntax of Jack. And so once you have all of this, which covers different facets of the Jaseki programming language Jack, then you try to combine all of these text files and then create the full LLM docs that cover all the material. So in version 1, we were trying to fully mimic what LLM docs had. So if you go to LLM docs, you can see they have four versions, four documentation types. That's full, minified, core, and slim, going from extremely small to extremely full. And so we tried to mimic that here. But through some of my testing, I realized it's four versions, four types are not needed, and realistically, you would only have a small model and a small doc and a big doc, much like how like say AI companies name their models. Let's take like Gemini Flash versus Gemini Pro. So I think this is the most effective, and so obviously, okay, we've created these super condensed documentations. Right, if you open this is like, I think 4.2 kilobytes or something. Like, this is very compact. How I should test this for testing suite, again leveraging the power of LLMs, I had it read through the entirety of the Jaseki docs and create a test suite. So this is sort of the driver that I use to evaluate. And so this big benchmark file, there's multiple commands I can run, but this includes this can help generate your test prompts from this JSON file of tests. That's like each test has the required fields in here. Running benchmark on this test.json would produce test prompts, which is what you show to the LLMs for them to evaluate. So I'm going to walk you through my testing process in a second here, but you can use benchmark.py, which is the main driver, to generate these cases. You can use it to evaluate. You can make it do kind of A/B comparison, A/B testing for you. And so here's how I would test it. So you open up a Claude window. I'm on Claude Sonnet 4.5, the newest one, which I think is the best. And I would grab one of these commands here. And so this is Mini V3. This is currently my newest version, and I think the strongest version. And it would tell it exactly this. Note one thing here is that you can do this in Claude, which is you can just add and then specify like a directory or file. I don't do this because in my testing, this actually brings down the overall test score, and so it brings down the LLM's understanding. I think that having the LLM go and search and open that file itself has this extra, adds this extra layer of meaning to it and helps it understand what it's doing better. So I would just run this, and this is the same thing I run with all LLMs. I just change out the file name here, and then the LLM, the full prompt is in prompt.markdown. And so here you would see return single JSON object, and I put it to test/test documentation name, and that would be in here. And so I just have to run this, and then change out the doc name as appropriate. But you can run this. We can open another Claude window, and then we can run it with a different version. We can run it with the core. And so you would just go in here like this, and that's basically all you would do. I understand that this is not automated, and I haven't really thought about like a way to automate this yet, but you can see that it's reading what it needs to read, and here as well, just running with a different doc, and eventually I'll output it to the test directory, and with the power of editing, I will jump to when it's done. Like it's done. We have the output files here. You can just kill this, and you can see that it actually took quite a while. I would not recommend doing this at home. That probably took a lot of tokens. That's a lot. So I definitely wouldn't recommend doing this at home. This repo is available on my GitHub, but do with it what you will. We can see here the files are done, and then to show you the driver, we can first /benchmark. We can first evaluate a single test file. So for example, here's LLMDocs. This is a test that I ran without any training. So this is without any doc, without the LLM having read any doc. So if you run it with this, you'll see like a baseline, and here it says 60%, which is actually quite high, and I'm surprised at how well it did on here. But I'm guessing it has some previous Jack knowledge from scraping the web however many months ago. So it doesn't completely fail, but it does fail quite miserably at the more advanced ones. I guess, what did I do? If we move this out, and then we run benchmark eval all, that'll evaluate both these files in the test directory, and that'll give us a report. And so we can go here and read this, and you can see that percentage wise, these two are actually a lot different from my testing. After some testing, I was able to get these up to about 80%. So this is actually a bit interesting. This is not what I expected, but as you can see here, this is the report it would generate. It would tell you doc size, score, percentage, the score that it got overall, and you can go through the more detailed breakdowns below. It's actually surprising because yesterday, if you read the docs, if you read the reports I got at the end of yesterday's training, these were actually quite a bit higher, 89, 87, with Mini having an advantage. So this is actually interesting. But yeah, as you can see here, core in this test, core comes out with a slight advantage, about 2% and a bit. But again, these tests are not always the same. LLMs can perform well and can perform poor in a given test. So there's a lot of variation, which is why I do a lot of tests. But through my more extensive testing beforehand, Mini has actually come out on a lot of instances, and I think that may be because a smaller context window and just the nature of LLMs not being able to process as much information. They can't process all 32 kilobytes of LLM docs that we throw at it, but that's kind of how it tests. And if you compare this with the baseline, this definitely brings up the performance by a lot. And so if you were to use the mini doc, which is actually very small, 4.90 kilobytes, I ran this through the tokenizer, the OpenAI tokenizer, and this came out to like 1,300 tokens, which is like nothing, because like these tests alone, if you look at these tests alone, like outputting the thing took 4.9 thousand, and I think you can't see this now, but like just the thinking process took like 20,000 tokens. So this is like nothing. This is, if you use the mini model, this yields like a very high ROI. So that's LLMDocs for Joseki. Do with it what you will. Use this to vibe code your projects. Get on the Joseki stack. But yeah, that's LLMDocs, and I'll see you some other time.